Please welcome Distinguished Vice President Analyst and Gartner Fellow, Gartner Research and Advisory, Daryl Plummer.
Hello everyone. How are you doing this afternoon? Last presentation of the day, right? Good stuff. Well, welcome to the New Economics of Technology and Data. Now, when I do speaking, one of the things I always remember is they say to do a great presentation, you always have to start with a joke. But as I was putting this together, I realized there's nothing funny about economics. I talked to several economists, and I asked even some of them to give me a joke. They tried. It was sad. I mean, you want to laugh, but it's more embarrassing than anything, so you get that kind of nervous giggling that you do. It's like going to a Chris Rock concert, and he starts talking about Will Smith. I mean, you want to laugh, but your brain is screaming at you, no, Chris, no, don't do it. And you just have to go with it. So that's what I had to do here, is just go with it. Economics, nobody likes economics. And it's a complex subject. So I'm going to try to keep it simple and just get you rolling on some of the things that you can use it for. So let's start with this notion. If you're in a fast-paced world, you have to realize something. There are many signals around us telling us what we should do and what we maybe shouldn't do, what we can wait on and what we really need to jump on right now. If you miss those signals, you may be waved off, as they say. If you've ever seen two ships trying to dock at sea or a plane trying to land on a carrier, they might get waved off if they ignore those signals. And the thing is that in today's uncertain world, if you get waved off, you may have to go around, but the boat might not be there when you get there. That's because things are changing so fast. And in the technology space, if you miss the signals, you may never recover. This is the problem we have increasingly, is we don't have time, and sometimes we don't even feel like we can do it. Our research shows that only 35% of us, only 35%, actually believe that innovation is their best of breed or that it's a part of their DNA. Just 35% of the people we survey feel that way. And that essentially means we're not built for it. Everybody tells us to move faster, but we're not built to do that. And so we have to figure out something that can give us an advantage. Now, a little evidence of that. When we start thinking about the last 20, 30, 40 years, we recognize that things are happening. Remember back in the days when we had mainframes as our main mode of operation, right? And everybody said, mainframes are going to go away, going to die. Anybody still got mainframes? Somebody still got a mainframe somewhere. You have my sympathy. But it is the reality we face. They're still around. It took us some 20 years to go from the concept of mainframes as a normal thing to something we used to call service-oriented architecture. Now, a lot of people say, service-oriented architecture, that failed and so forth. It didn't. Everything we do is service-oriented architecture today at some level. And the reality is that 20 years was a long time for us. Now, to go from a service-oriented architecture through mobile computing, APIs and cloud, it's taken us more like 12 years. And then we go from there, we hit the digital age, that goes down to something like 6 to 8 years. And quite frankly, the generative AI world is going to be 1. You're getting put into a situation where the pace of change is speeding up so much, and you're constantly asked to do all these things, and before you can finish one, there are 2 or 3 others that are ready for you to start on. So if you feel a little bit harried, if you feel like all these technologies are just swamping your organization, you're not alone. Because many people are in this situation where going from just a relational database to synthetic data is not a simple thing, right? This is something that we all are facing and we all have to realize. But the problem is, sometimes you feel like you can't catch up. We've got too much going on. And we have to get past that. We have to move from catch up to keep up to leadership. And I'm going to try to talk to you about one way you could use to do that, okay? So when you're looking at signals, A key to transforming your DNA initiative is in reading those signals early and correctly. So I want you to think about economics as a means of getting there, because really there are many different kinds of places or categories where signals can come from. You could start thinking about social signals. Now you all know that we're a social community now. Everybody's on so. Just watch people walking around the event. They walk like this, you know, and they're probably doing social media. You know, they're probably trying to post something or read something of what happened in the world. They get their news that way, they communicate with their friends that way, their family that way, and even get information about their job through a social channel these days. So the signals there say people will be social. And one of the negative ones is because we're hiding behind the keys of a social media board, we can be mean to each other now. But the reality is that we have to live in that world. So mean or not, we're going to be social. So the other systems are there, political systems, behavioral systems, all of these ways to get safe. But the one that makes a big difference is economic systems. And the reason why? Money. That's where money is made, spent. This is the place where you start thinking about the potential for things to change. Now, if everything changes in social media, you could ignore that. But when who your customers are changes, or how much money you spend, or who you have to sell to changes, you can't ignore that. And because of that, the idea of economic potential is now very key to your ability to lead. You have to look at what the economic potential is behind something to know when it's a big deal and you should jump on board. Do you remember back in the 1990s? I love to talk about the olden days, okay? Back in the 1990s, I go a lot farther back than that, but I remember a conversation where Steve Jobs was talking about separating the song from the album and selling them $1 at a time, $1 a song. Remember that? And the RIAA, the record industry executive, said, no, it'll never work, you can't do it, we don't want nothing to do with it. Well, Steve Jobs wasn't thinking, I want 2 points more margin from this software product I'm going to release. He was thinking the economic potential of separating the song from the album is exponentially larger. And as a result, we've changed the way that people find music, the way they consume it, how frequently they buy a song, whether they buy an album or not, and even the distribution method that artists use to get their music to people. So we see the change in the economic potential that was behind. And even Steve Jobs missed the streaming music world. So we went from just iTunes buying a song to paying for a streaming service where we were able to get all the songs for one cheap monthly price that keeps going up. But we all see the potential in that, and we know it. Now we know music comes from everywhere. Now, I used to tell a story all the time. I haven't told it in a long time, but I'm going to tell you here because the streaming music thing has got me a little bummed. Because I am a vintage stereo guy. I design and build my own stereo speakers, and I'm serious about it. My motto is, as a man like me, if your speakers are not bigger than your wife, you're just playing games. Nobody should have those tiny Bose cubes in their house. And quite frankly, if your wife is not happy with those giant speakers in her living room, you got the wrong wife. I'm serious about it. But the world has changed. The economic potential of stereo speakers is nothing today. The economic potential of streaming is everything. So that's what we're talking about. Look for the economic potential to change, and you can get a signal of when you should move to the new thing. So that's how we're going to talk about it. Now, I'm going to give you some principles to follow. These are ones you should write down. Take a picture because you should be looking at these principles all the time. There are many economic principles. I stuck with these 5. The first one is supply and demand. Now, you know supply and demand, right? If they want it, you need to supply it. If you have enough of it, you can sell it. Right? If supply is low, demand, it may be high, but the cost goes up. So that equation is interesting. If you see change, if you see, like with Steve Jobs, you see people starting to say, hey, I want music $1 a song, but I'm going to buy hundreds of songs now, not just a few albums. Something is shifting in the supply and demand equation. The artist will generate more. You also see things like scarcity and rarity. How much of the resources are available to you? Can you get to things? This is one of the reasons why I liked the concept of NFTs. Anybody still bought into that Ponzi scheme? No, just me? I liked NFTs because NFTs were a unique identifier for a digital asset. And you know the problem with digital assets? You can copy them as many times as you want. So there's no rarity, there's no scarcity of it. And so the value of them goes down the more people copy them. But if you have a unique identifier, you can make it so that one person owns it and anybody who copies it is breaking the law. That drives value up. So look for things that drive value up in terms of rarity and scarcity. The third one is value and outcomes. Look for value scenarios. When something's valuable that you can monetize. It used to be going to the beach was a value scenario. You know, you could go to the beach. They used to charge a toll. I used to live in Fort Lauderdale, so they used to have a toll to get to Dania Beach in Fort Lauderdale. And it was, but we paid it because we wanted to go to the beach. Then at some point, going to the beach wasn't enough. You needed to go to the beach and call your friends from your mobile phone on the beach. You remember those first phones? You know, you would go to the phone, get a friend to help you pick it up, dial people and have your conversation. That was a new value scenario. Then it became, while you're on the phone, you can order clothing for your next beach trip. New value scenarios are coming up all the time. So look for those in the technology that comes around. So this is how we do this. When we look at these things, we've also got the idea of cost versus productivity. If it costs less and you can do more, that's a big shift. That's potential. And if desirability and motivation changes, that's potential. How many people here own an electric vehicle? Okay, a few, all right. Now those who were in my last presentation know where I'm going, right? Electric vehicles at one point were not cool. You remember the old, the old electric vehicles? When you saw one driving the street, you kind of snickered a little bit. Look at those guys. You know, I mean, I have a used Maserati. You know I'm laughing at every electric vehicle that drives by. But at some point, electric vehicles became cool. The designs got cool. The battery lifetime got better. And the cars got faster off the line than my Maserati. And that was an interesting change to motivation. So now I got to go buy an EV. I mean, Kevin Bacon is driving one. I might as well do it. Haven't you seen that commercial? Kevin Bacon, he has a fanny pack and an EV, and his daughter makes fun of him the whole time. So the notion here is that the desirability and motivation around EV, you get the point. Economic potential is shown through these principles. When they change, maybe your buyers change, maybe your price point changes, maybe the value of the whole system changes. So there is what we're talking about. When you get to these things, things start to change. And when the economic potential changes, I like to say it this way. This is from an old, I think it was Herman Melville, there be whales. When economic potential changes, there be signals. Those signals will tell you, jump on now, or maybe wait till later. So here's what we're going to do. Rest of this presentation, I'm going to go through this path. There's a path from disruption to leadership. Technology is going on. You can see what the economic potential change might be, what the outcomes could be from that if you follow them, and what you should do about it. All right, so let's start. The first area I picked is one that my colleagues have told me, that's not a new thing. It's something different. Well, it came from a quote that I love. Rose Kennedy once said, life isn't a matter of milestones, but of moments. The notion here is that we all think our lives are about the milestone. When did we graduate college? When did we get married? When did we have kids? Those milestones. But really, what really is meaningful in our lives are the moments we go through, the sequence of moments we all share and we all enjoy. And that leads us to the concept of time series data. Now, somebody in the audience is sitting out there thinking, hold on a second, I paid all this money to come to Orlando, Florida, and some Gartner knucklehead is on stage telling me time series data is important like he just discovered fire. We've been doing that forever. Yeah, well, let me tell you a little story. I was in Johannesburg, South Africa. We travel a lot in this job. And I was with another analyst, and we were supposed to fly home, and they canceled our flight. And I went and got the Holiday Inn on the airport, and I stayed in my little tiny room. It was clean, but it was small. He went downtown to Johannesburg and checked into the Ritz-Carlton. So he comes back, and I said, where were you? I didn't see you at the hotel. He says, I was at the Ritz-Carlton downtown. I said, I'm at the Holiday Inn. He says, Daryl, you travel a lot, but you don't travel well. And that's what I'm going to say to you here. Maybe you've done time series data, but you haven't done it well. And now you need to do it well. And that's going to mean a lot of things that are going to change you. You could even look in places like Star Trek. I'm a big Star Trek fan, like you couldn't tell. You know, Star Trek had the temporal prime directive. Now, you might not remember this, because you remember the prime directive was when Kirk would always say, we can't interfere with a pre-space going society. That's their #1 rule. Well, in the show Star Trek Enterprise, they introduced the temporal prime directive, where they said you can't interfere in time. So even in Star Trek, they had temporal data. And now, here we are in the real world, and temporal data is driving us to generate temporal data warehouses. Now, I know you're thinking, DB2 had temporal columns quite a while ago. A lot of companies have temporal data now, and we're seeing more of it come along. But the reality is, temporal columns are not enough. You've got to be built from the ground up to handle temporal data at speed. You've got to be able to do it effectively and consistently across all of your projects to get the kind of economic potential change that I am talking about. So it's not enough to just say we have temporal columns. Right now, you can go and see a lot of companies that are doing temporal stuff. You can see, companies like DataRobot, QuasarDB, you see it, but you see the ones that are re-architecting to support this are interesting. And what are we talking about here? First off, digital demands time. We're in a digital age today. And in the digital age, you have to have two things that we have not done well: time series data and geospatial data. Now, I'll come to geospatial in a minute, but the reality is that digital is best when two things happen. The virtual world merges with the physical world. That's real digital. It's not just using a mobile app. It's not just having a website or just running your business on computers. It's the merger of the physical world and the virtual world to create new value and outcomes. I'm talking about the fact that if a car is going to drive itself, it has to be able to see the other cars on the road. If a drone is going to fly itself, it has to be able to not run into trees or the window at your house. Birds run into my windows all the time. Why do birds do that? Well, they don't have enough data. That joke got away from me, I'm sorry. But the notion is that we need to not run into windows here. We got to have data that allows us to do digital things effectively. That includes being able to evaluate things over sequences of moments. Time series data now becomes very critical to what we do. And so if digital demands time, we have to take our data warehouses and not just force fit the data into them. We need to create temporal data. We're going to add it to our other layers. Our logical layer is BI, the SQL that we use for it. Our data science and ML, which we've been talking about for a while, which is now starting to come to fruition. And we create what I call a temporal data warehouse. A temporal data warehouse. It will keep time and distance, time and motion information. It will keep relative data. You can do regression analysis on time. You can look back over large periods of time or roll forward and then to begin to anticipate what's going to happen in the future, not just stamp it with time. You have to be able to operate across time to make things better. Now, here's a claim. I mentioned these vendors. One of them is KX Systems. KX Systems makes this claim that a temporal data warehouse, they call it a time house, is 100 times faster and 1/10 the cost for temporal data. Now, is there anybody out there who doesn't think that 100 times faster at 1/10 the cost is a pretty big economic potential? Now, if it's true, that's great. If it's not true, it's a nice thing to aspire to. And the notion is that if we have temporal data warehouses, we can do more with it. So how do we tie this back to the economics? Let's look at economic potential in clinical trials, for instance. A faster clinical trial launch is worth $1 million a day. That's the supply and demand issue. More clinical trials, more clinical results. So you're going to really look for the potential of being able to save that kind of money and do more at the same time? It's really not just a supply and demand issue, it's a cost and productivity issue. So we also look at this idea that when you start thinking about this, getting candidates recruited for a clinical trial is not as easy as it might sound. You have to do analysis of diagnoses of the patients over time to know which ones fit the clinical trials you have going or you're trying to spin up better. So time series data is necessary to look at the patient information, to look at the diagnoses over time, what trials they may have been associated with in the past, are they in control groups, and use that to build more clinical trials. And in the end, we can look at this and realize that successful clinical trials will occur. And that will save anywhere from 10 to 100 million on a successful trial. This is economic potential in clinical trials that we should not ignore, and this is repeated across many different industries and many different scenarios. In finance, of course, we can look for fraud detection when we start talking about temporal data in finance. When we look out there in manufacturing, what is the process doing over time and is it effective? Everywhere you look, time series data is useful. And when you think about it, you need this kind of support. Now, what I'm talking about with clinical trials, Syneos Health has done this. And Syneos Health has really enriched their global studies, their ability to do patient recruitment, their ability to do investigation about trials. They've enriched it with temporal data everywhere. They're using a time house. They're using it to get better results and greater economic potential from it. And so when you look at this, they have created something they call virtual clinical trials. We're talking about doing 100,000 simultaneous simulations of clinical trials across 1 billion patients. That's an economic potential you cannot ignore. So don't think of temporal data as just something that, oh yeah, we've got timestamps, we got temporal columns. You need to go farther and see how it does it. So many of the CDAOs that we see are force-fitting temporal data into a conventional data store. And my advice, stop doing that. The best practice is first to avoid worst practices. And that is a worst practice, force-fitting temporal data into conventional data stores. So this is what I'm talking about. How do you find that potential? It gives you the signals on what to do next. Follow the path. New technology comes along, economic potential has changed, you get to certain outcomes, and then there are leadership actions. Let's try another one. I mentioned geospatial data, and there's a phrase that I said this, we say Gartner, but I said that when a physical thing can be reduced to data, it's ripe for economic change. Now I did this because I think a lot about the physical world, and when I think a lot about the information about who's sitting next to you, how far are you away from another person in this room, how cold is it in this room, how warm are you, and how long are you going to be here listening to that guy drone on stage. These are things that you really, really need to think about to be able to make sure your experience is what you'd like it to be. So let's talk about the Earth. When we talk about geospatial data, there's something interesting going on. There's something interesting here because Google Earth Engine has taught us something. It's taught us something about using geospatial imagery from satellites. There are a lot of ways to collect spatial data, right? You can even collect spatial data of people in a video game environment. In a virtual world, you realize people are actually interacting through spatial relationships, virtual spatial relationships. There's information in the game that really good gamers can use to win. And in the real world, the same thing is true. And when you look at the Earth Engine, we're looking down on the entire planet. And they've taught us, in the end, that when we're looking down from satellites, it's all data. It's all data. They have created essentially a digital twin of the Earth. A digital twin of the Earth. Now, Benoit Leroux, who was one of our analysts who introduced this idea of digital twins, and I said this phrase to him, and he said, "You don't think small, do you?" And I'm asking you not to think small. We're talking about satellites looking down over every inch of the Earth and evaluating what's happening, potentially over time, because Google Earth Engine has data that goes back 40 years. And when you're able to do that kind of thing, you're able to do geospatial data in a way that is very interesting across a lot of domains. Climate change. You can see climate change from space. You can see icebergs melting. You can see the flow of warm water in the currents of the ocean as it moves. You can see these things from space. You can see ports being managed from Antwerp to Fort Lauderdale in one view, looking down from space. So geospatial data gives you a way of actually doing a lot of things, even supply chain management. There's a company called Gojek. Gojek uses AI and geospatial data to optimize the supply chain and logistics, where trucks are running routes around to deliver things, pick things up, or to fulfill the logistics in a supply chain in general. Well, the interesting thing is that a truck that's leaving the warehouse with fully loaded is more valuable than a truck coming back that's empty. If you use AI and geospatial data, you know where the trucks are, what the road barriers are, what the traffic looks like, how the trucks are doing on their route management, where are they going to be at a certain point in time, and you could even build routes that allow them to pick up goods along the way so that they can keep the truck full throughout its entire cycle. So this route optimization that Gojek does using AI and spatial data is making an economic difference for logistics. So this is where you can use this. Again, we have used geospatial data. I mean, now, Snowflake has added spatial data. Everybody's adding spatial data. But you've done it, but you haven't done it well. And digital demands it. You need to know where it is. You need to know how long have those goods been on that pallet, on that truck, driving on that route? How hot did they get? And did they get vibrated too much? This kind of information is essential for good digital scenarios. So time series data and geospatial data come together in that way. So what about sustainability? That's one that everybody loves. The economic potential there comes about because you can collate business physical locations to sustainability risk, where they are, and what does that mean to sustainability. You can get observable Earth data injected into the equation, and you can see the impact of that data. This is something that we see. So right now we're seeing in sustainability that we see 7 times faster growth for sustainable products over products that are not sustainable. 7 times faster growth. That's an economic potential I like. We also see the idea that 65% of people say they want to work for a sustainably oriented company. That's desirability and motivation to get people to work for you instead of working for someone else. And 1/3 of all investments in 2021, investors said needed to be under some kind of a sustainability mandate. So now we're talking about our investments becoming more sustainable. It's not something you can ignore. And all of that through sustainability data. 2 more quick examples. Tracemark, in GIS, Tracemark does global monitoring for deforestations. If you're going to get raw materials, do you want to get them from someone or some place where deforestation is happening or not happening? So monitoring for it and doing analysis about deforestation can help us understand. They're looking across 70 petabytes of data, spatial data and time series data, to allow them to know where deforestation is happening and where it is not happening. So it's a very good thing to get this right. So remote monitoring, prioritizing the on-the-ground inspection, but all from looking down from space. Now a little more down to earth, BMW. BMW is working with SageMaker from AWS. Amazon SageMaker is an AI, a machine learning environment that allows BMW to track things like how people drive their cars and electric vehicles. Where do they drive them? How long does it take to get to a parking space? Or how long does it take for them to find an electric charging station? And it's helping them to design where those charging stations should be, even eventually helping them to design how cars work. And all because SageMaker gives them the analytics to be able to take advantage of the geospatial data that comes from GPS tracking, from in-car sensors, to understand what people do with those vehicles. So it gets better every time that they use these. Economic potential is built. So you have to treat global physical world data as more critical to digital transformation than any other kind of data. This is a statement that I make strongly because so far you haven't done it. And it heralds some changes that you might not expect. Some of you may have seen already. First, analytics will cover real-time, globally integrated processes. I can know if a ship is leaving Antwerp and is going to Fort Lauderdale, what's the port going to be like when it gets there? What's going to happen if that ship is not able to be unloaded and a cloud of pollution is built on top of an iron ore shipment because they weren't ready to receive it, or a wheat shipment from that matter? We can track the pollution cloud as it moves across the city. So we do globally integrated processes to make better overall process success. Secondly, there's going to be the end to the field agent jobs. Do you remember when you had a problem at your house and you had to call an insurance company because there was a hailstorm and your roof was damaged, and they always told you there was no real damage? They send someone out to climb up on the roof of your house, hopefully not fall off, and then do the underwriting and tell you whether you're going to get money. Now they send drones to do it because they don't need to have a person go out. You could also see that from a satellite. These kind of changes are coming about because geospatial data is easily accessible. So we get smarter processes, we get greater customer satisfaction. All that stuff comes from the fact that we're ready to use this spatial data better than we've ever done it before. Economic potential. Okay, so I've hammered the point. Economic potential will change. That's what you should use to tell you when you should lean in and when you shouldn't. And I'm telling you right now, it's time to lean in heavily to time series data and geospatial data. You haven't done enough with it. And you will find digital advantages for transforming your company if you do that now. But it's not that easy to say that about everything, because a lot of times there's signal, but there's a lot of noise around it. So how do we know, a technology change heralds a true disruption, and we have to separate the signal from the noise. So I'm going to use an example here. I always ask myself these kinds of questions, like, what is the loudest sound ever recorded? The loudest sound that's ever been recorded. The answer is fairly straightforward. That is the actual recording of the explosion of the island and volcano of Krakatoa in 1883. That sound was loud. That sound was heard 4,000 kilometers away, 3,000 miles away. That sound created a sound pressure wave of 172 decibels at 99 miles away. That's louder than a jet engine the shuttle taking off when you're standing next to it. That sound pressure wave traveled around the Earth 5 times before it dissipated. That was a loud noise. But you have to ask the question, was it a lot of noise or was it a true disruption? What's changed in your life because Krakatoa exploded? Not much. The reality was that as loud as it was, most people went back to normal after the explosion happened. Unless you were close to it, you're doing okay. So the idea of being able to change anything through a disruption means you've got to have a lasting effect. You got to be something big. Now, I said that's the loudest sound ever recorded. I didn't say that was the loudest sound ever produced, because you know what the answer to what is the loudest sound ever produced? It's a simple answer, ChatGPT. Now, you probably heard a lot about ChatGPT this week, right? Have you heard too much about it or not enough? Everybody says ChatGPT, ChatGPT. ChatGPT is rapidly becoming the Kleenex of the AI world. Or I could say the Band-Aid or the Hoover. It's the brand that becomes the thing. And everybody else is saying, oh, that AI thing over there, that's like ChatGPT. So it is loud. The hype is high. Everybody's talking about it, and it's pretty amazing stuff. So when you think about this, you have to start asking yourself. One guy took ChatGPT. He gave it a picture of the stuff in his refrigerator, and it gave him back recipes of what he could make from those ingredients. Right? He sent it to Visual GPT, and he got back those answers. Another guy recreated the video game from the 80s, Pong. You remember that? Bloop, 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 bloop. Recreated it with GPT-4 in 60 seconds. A working video game, 60 seconds. We have seen people do things. I saw a guy write a story, asked ChatGPT to write him a story. And then he said, now, redo the same story, but first review Kurt Vonnegut's rules of writing. He said his 12 rules of writing. ChatGPT came back and said, I can't find 12 rules of writing for Kurt Vonnegut, but I do see that Kurt Vonnegut did 8 rules of writing. Here they are, and here's the new story. And he changed the story. So the other story was kind of like, it was a summer day. People were nervous about events that were going on because they didn't trust one another. That was the first story. After he wrote Kurt Vonnegut's rules, the story was, she waited in the back room to kill him when he arrived from work. If you read his rules, you know why he changed the story that way. The idea of what Kurt Vonnegut thinks makes a good story is what ChatGPT used to change the story. So we're talking about generative AI being able to do some amazing things. Alan Turing created a Turing test. It was a test where you could ask questions of an anonymous responder and then tell whether it was a human being or not. Okay? I have devised the Plummer test. What I do is I ask ChatGPT questions, and then I post the results to Facebook to see if anybody knows it's me. Okay, so far, nobody cares. All right? By the way, for those of you not familiar with Facebook, it is a social media platform for people who are mostly afraid to use TikTok. Some of you may not know that. So the idea, though, is this world is changing. This is the year everything changes. Generative AI becomes real for all of us. And if we want to use it, the economic potential in it is great. Okay? The economic potential. What does it have to do with economic potential specifically? Well, the answer is that hidden in the noise of ChatGPT, which is loud, are new risks and opportunities. New risks and opportunities. That's the mantra of the man who wants to make money. That's the mantra of the woman who wants to succeed. That's the mantra of my children when they want me to give them money. There are new risks and opportunity, Dad. Come on, I need money to do it. And right now, I got to ask ourselves, are we ready to put money into this generative AI thing? Answer should be yes, we are. Because generative AI is changing a lot around us. We talk in disruption about secondary effects. If you're going to have self-driving cars that can pick you up at any time, why do you need to own a car? And if you don't need to own a car, why do you need to have insurance for a car? And if you don't have insurance for a car or own a car, why do you need to have a garage on your house? Why do they need parking garages at your corporate offices? All these things are secondary effects of self-driving, shared ride vehicles. So if you look at the secondary effects, a lot more synthetic data being generated, artificial data created by artificial intelligence to support generative AI. We're looking at industry shifts. If you're in education, you're scared to death right now. I talk to my friends in education, they say, I don't know if the kids are writing their reports or they're getting ChatGPT to write it. And my answer to them is, why does it matter? You shouldn't be teaching them how to write the report. You should be teaching them how to evaluate a good one versus a bad one. Who cares who wrote it? Change your thought process. Change the way you think about this, and you can see the signal in the noise. So there are new skills that are coming out that we have to pay attention to. The path is still there, and a new skill comes from it. Let's look for a moment. If you do not know how to ask the right question, you discover nothing. William Edwards Deming. Now, he was a management consultant, so he says stuff like that. Don't listen most of the time. But this was a good one. This was a good one. If you don't know how to ask the question, you discover nothing. Prompt engineering will be one of the coolest skills in DNA over the next 5 years. Well, the next few years, actually, because it's going fast. Now, why? Because anybody can do prompt engineering. Has anybody studied or done anything with prompt engineering yet? Just want to know, have you guys picked up on it? A few? Prompt engineering is when you engineer the prompt to get a better answer in the end. Right? Prompt engineering is what anybody can do. I asked ChatGPT, remember I'm a Star Trek geek, I said, which one of the starships named Enterprise would win in a one-on-one battle with all the others? ChatGPT came back with something like, well, it's impossible to determine because we don't know what the conditions of the battle, shut up. So I went back to it. This is a very trivial prompt engineering thing. I went back to it and I said, okay, use this context. The original Enterprise had 50 photon torpedoes. The Enterprise A had 200 photon torpedoes. The Enterprise D had 2,000 photon torpedoes. Now answer the question again. And it came back and said, based on this context, the Enterprise D would win in the battle because the others would run out of photon torpedoes before they got through the shields. That's a simple, trivial example of prompt engineering, but it can get a lot more complicated than that. Prompt engineering is what some people do. Now, I have a different view of prompt engineering than a lot of people because I think it should be something much more critical and much more integrated into what you do in your DNA practice, not just a user of ChatGPT doing whatever they want. So I look at it this way. Prompt engineers should be there to help you understand and expand the knowledge that's available and to validate and verify the results. That would be a good thing for a prompt engineer to be able to do. They're going to go on the understand and expand side, inject new knowledge. You got to be able to set context for the question by giving it more information. Remember the photon torpedoes. Give it a little more information. You've also got to be able to set the context across different types of LLMs. Some of them are Q&A style, some of them are translation style, some of them are calculation style, and a prompt engineer can bridge the gap between them by asking questions and setting the context the right way. On the other side, you've got to secure knowledge. There's something called prompt leakage. The simplest way I could think of this, and this is, there's a lot more to it than this, but the simple way I can think of this is, if you give a prompt to a ChatGPT and you insert corporate data in that prompt, that data could be used to learn, and when someone else asks a question similar, they'll get your data. So you're leaking data out through your prompt to the rest of the world. You don't want to do that. So prompt engineers will be careful about that kind of thing. And they're going to promote the right answers, not the wrong answers. You've heard people say it, sometimes GPT just makes stuff up, and you don't want AI making stuff up. But they're going to do it so much, we won't even be able to tell when they're making it up. So you got to have people ready to do that. So that's one skill that's going to be cool. And why will it be popular? Because anybody can do it. Anybody. ChatGPT is all about the prompt, but it's nothing about the model. In other words, you don't use ChatGPT to change the large language model itself. That's done through LLM fine-tuning, where you're able to give it some of your own data in a private context and fine-tune, do the inferencing for the system and do learning on your data. And then you can ask questions about your data. Now, I don't know if you realize, but most of these LLMs take months to do the inferencing for them. So they're almost never going to be up to date to the moment. If you ask one of them, hey, what's the best stock today? And I know some of you have tried, because I tried. It will say something like, well, I'm a large language model. I don't know anything about stocks currently. I can't look at that stuff. You know, but you can train it to look at stuff that you care about. And that's a good thing for a fine-tuning expert to do. Now, this is not something that everybody can do. This is something you need specialists to do. Data science people, and they're going to have some programming skills. Prompt engineers maybe would have them too, but not generally. Citizens do prompt engineering, professionals do language tuning. Those are two things that you want to do in here. So let's look at some of the potential behind all this stuff. Prompt GPT generated 10 to 15 million prompts per day. 10 to 15 million per day. New value and outcomes? Sure. You can get answers to questions you never could before. Likewise, it costs the estimates range up to $4 million a day to run it. You think you're going to run your own large language model? You got $4 million a day to run something like that? You're not going to run your own. You're going to use an API to GPT-3 or GPT-4 or ChatGPT or Bard or something else. And the notion is that you will get value by using those technologies. And Bing took what? You know, if someone hears from Microsoft, you know, this is not the Oscars. Don't come up and slap me if I get this wrong. I think Bing search took like 10, 12 years to get to 100 million users. And ChatGPT did it in less than 2 months. We're talking about massive economic potential behind generative AI. And if you do it right, you can get a lot of value from it. And it's not just GPT. It's not just OpenAI. Google AI, Anthropic, a whole host of them. Even Amazon, AWS is getting in the game. They haven't announced a lot of the stuff that they're working on, but watch this space, because everybody's getting into this thing. And you'll see the amount of options you have going through the roof over the next year. This is the year everything changed. So these are the things that we can do because of this. Order of magnitude leap in data, queries and users that you have. Context setting across LLMs will become a thing. Learn what that means, right? Across LLMs and within a given LLM. And certainly, you've known about Hadoop MapReduce. But there's this new thing out there, only one of many, called Langchain, that allows you to generate templates for prompt engineering that are complex templates to get the right answer from your generative AI. So now's the time. Lean in. Don't think that there's nothing to do here. In fact, one thing you should be doing when you meet data scientists who have Python programming skills, most data scientists don't. Most data scientists couldn't tell you what a program was if you asked them. They don't want to know. They're data scientists, not programming geeks. Now, I've been a programmer since I was 13 years old. That makes me, by definition, a programming geek. But they don't generally do it. When you meet ones that can do both, hire them, because they will be helpful in your transition from just prompt engineering all the way to LLM fine-tuning. So these are the things that can happen. Where will you look for signals? Where will you look for economic potential to grow? If you really think about it, we all have economic potential on our minds. And that's why I leave that as the main thing you should be looking for in signals that tell you when to act. And in the end, you have to think about separating that signal from the noise. And here's some things you can do. First, find the important patterns. Don't just see it happen once. Look for things that happen over and over and over again. I mentioned ChatGPT can what recipes you can make from the food in your refrigerator. But the patterns for what it can do are being generated every day. Join a community where they talk about those generative AI patterns, and you will find things that you go, oh my goodness, I didn't realize I could do that. And I need to do it for data and analytics. The second thing is challenge your status quo assumptions. Don't assume that the things you've always assumed are still true. Nothing is sacred. You have to challenge it all. And then you'll be able to change faster. Third, avoid momentary excitements. I asked in my other presentation, I'll ask again, is anybody here still playing Pokemon Go? Anybody have a pet rock? Cabbage Patch doll? You know, those were momentary excitements. Big hype, and then they went away really quickly. Disruptions get a big hype and then stay over time. So avoid the momentary excitements. And lastly, seek those secondary effects. The things that happen because a thing happened. You know, I mean, a rock falls off a mountain into a calm lake, there's a big splash. That's a catalyst for disruption. But the ripples, the waves that radiate out from it are creating the secondary effects. If they're big enough, they could swamp ships, change the shoreline. And you have to be prepared for that, because if you aren't, you're going to wind up lost in the noise. Nate Silver once said, Nate Silver was a statistician, or is a statistician. He said, the signal is the truth. The noise is what distracts us from the truth. You know what he did with all that? He became a poker player and made a lot of money. Economic potential can make you a lot of money. It's time to get on board. Thank you very much for listening, and enjoy the rest of your day.